In this video, I'll teach you the skill of rapid estimating and order of magnitude. So what's an order of magnitude? An order of magnitude refers to the exponent of 10. Kind of like scientific notation. For example, 10 to the power 3, which is 1000, has an order of magnitude of 3. I'll give you an example to solve for yourself. What order of magnitude does 10 to the power 6 have? The order of magnitude of 1 million is 6. Why is this useful? For estimation. Let's say you used a calculator and you got a really big answer. You can use your rough estimating skills, which I'm going to teach you today, to quickly check if you're in the right ballpark. It checks if you're kind of right. It's like a sanity check. And it saves a lot of time when a thorough calculation is not worth it or necessary. I'll give you two more quick, super basic examples before we move on to the proper examples. So we want to know what order of magnitude a car is. Well, a car is roughly equal to 1000 kilograms. We can say that, right? 1000 kilograms is equal to 1 times 10 to the power 3. So that means the order of magnitude is 3. The second example, let's say you have an iPhone. And an iPhone, we can roughly say that it's 0.2 kilograms. 0.2 kilograms is equal to 2 times 10 to the power of negative 1. So the order of magnitude for this iPhone is negative 1. Now for a bigger problem. Let's say you have a lake. A lake in the mountains. Very pretty, it's sparkly and it's sunny. Now the lake is 1 kilometer across and it's roughly 10 meters deep. How would you quickly get a rough estimate for how much water is in the lake? Let's use a cylinder model. Of course, lakes are not perfect circles or perfect cylinders, but remember, we just want a quick ballpark figure. Avoid getting caught in the details. Now, what's the radius? And we want to find the volume of this cylinder. Now, the radius of this cylinder is going to be 500 meters. And we get that from dividing the diameter of the lake by 2. The depth or the height of the lake is 10 meters. There's our two values, and we can use the volume formula for cylinders to find how much water is in the lake, roughly. The volume formula is height times pi r squared. So this would be height times pi times the radius squared. The radius squared is equal to 25,000 meters squared. We've just plugged everything in. Once you solved it, it's roughly 7.5 times 10 to the power of 6 meters cubed. We're going to round this to one significant, so that would be 10 to the power of 7 times meter 3. Now, why do we round it to just this? Why not keep this more precise answer? Well, that's exactly why. We don't want it to be too precise. That can actually be misleading here, because we're working under so many assumptions that a more precise answer can actually be misleading. So it's better here to actually quote this answer instead. Now here's a famous example from the super smart physicist Enrico Fermi. So if you've heard of the Fermi paradox, which is where are all the aliens, then you might know this name. He asked a question: how many piano tuners live in San Francisco? And he estimated it with logic. He didn't Google it. So San Francisco had about 800,000 inhabitants. So the first step is to estimate how many pianos are in San Francisco. First, we note that definitely not every person has a piano. It's reasonable to assume that every 1 in 3 households, so every 1 in 3 families, owns one piano. Now, if we assume one household is 4 people, then that means 1 in 12 people own a piano. As an order of magnitude, let's say that every 1 in 10 people have a piano, which is equal to about 80,000 pianos in San Francisco. 80,000 pianos. Let's rub this out, make some space. So let's assume that a piano tuner takes 1 to 2 hours to tune one piano. So in a day, a piano tuner can tune 4 to 5 pianos in one day. A piano needs tuning maybe every 6 months. So let's say once a year, okay? One every year. So that means, based on the super rough number, 80,000 pianos in San Francisco, we can assume that there's 80 piano tuners living in San Francisco. Now this number, obviously, it's not correct. You can't know it's correct. It's not meant to be precise. But what this tells us is that there must be more than 10 piano tuners, but there's definitely not more than 1,000 piano tuners. It's in between here. That's what this rough estimate has told us. Enrico Fermi was extremely smart. He made contributions to modern theoretical and experimental physics, which is almost a unique feat these days. It's very hard to do that now. Here's a homework. I challenge you to estimate with your new skills and your new knowledge of what an order of magnitude is. I challenge you to rough estimate something in your room. For example, the volume of your table or how much air is in your room. Fun little challenge for you, and put it in the comments so I can read it. I'm genuinely interested in what you guys do.